Okay, Markus, you created a new benchmark suite for ultra-low power microcontrollers. Why was it necessary to have a new benchmark suite? Can you explain?
Yes. So, as you're probably aware, the industry is always concerned about lower power, lower energy consumption, more and more and more. This trend keeps increasing with battery-powered applications, where people are expecting the device to last in the field for months, years, or even potentially in some applications, decades. And the developers of these systems today have to rely on the vendors to supply the right information, but unfortunately, every vendor provides different types of information depending on how they actually analyze their microcontrollers. So the idea here was to put a working group together within EEMBC that agrees upon the measurement mechanisms so that everybody is providing the same type of data under the same type of operating conditions.
Okay, Markus, there are various MCU types on the market, and they all, not all of them, but a lot of them are using different low power modes. Do you cover all these modes with your suite?
Yeah, it's actually a very interesting and bewildering question, because if you look at all the different low power modes and ultra low power modes of the microcontrollers, it's so complex that as a system developer or as a programmer, very, very difficult to figure out, at what point do you put this microcontroller into a specific mode. And so as far as our benchmarking is concerned, we're not really interested in analyzing each of the different power modes, but what we are interested in is allowing the vendor to provide the optimal low power mode configuration while they're running a workload over a certain time period. So some of them may choose to go into a complete power off mode, but of course this will also affect the latency when you're required to come back up to full operational mode. But our goal is not to define specifically what mode should be used, but allowing the vendors to express whatever is optimal for their configuration.
Okay. And if you look at the modern MCU, there is a small core and a lot of peripherals around it. Have you any tools to optimize the power consumption of the peripherals as well?
Yeah, that's an excellent question. And so from a strategic point of view, we're developing this benchmark in phases. So the first phase will be primarily code-based, where you run certain segments of code on the microcontroller with specific duty cycles. But eventually, the next phases of the benchmark will utilize more of the intelligent peripherals to allow you to offload some of the work from the CPU, which of course ultimately will lower the energy and the power consumed.
Okay. And do you think the customer or the industry will be happy to get your tool suite, or do you have to do special things to make it public or popular?
So it has actually been amazing at how popular this benchmark has been, and actually
there was a previous one.
For the record, the benchmark working group has just started recently, so we don't have the benchmark available yet. But just in talking to the semiconductor vendors, the system developers already, we're seeing tremendous interest in having the availability of this benchmark. And one of our primary goals here is to make this benchmark accessible, very easily accessible to any developer. And we're trying to come up with a mechanism where the energy measuring capability is actually integrated onto the evaluation board. So to utilize this benchmark will be very expensive and will be very inexpensive and very practical.
Well, are the first development boards available?
No, we're probably 6 to 9 months away from having availability of these.
Okay, thank you very much, Markus.
Thank you very much, Wolfgang.